Hello, Jaguar students. It's your friendly neighborhood math teacher, Mr. Allred, and I'm so excited to bring you to Unit 5, mini lesson number 6 on solving inequalities. Today, we're going to take all the things we learned on Friday about inequalities and what they are. We're going to start to solve some two-step and multi-step inequalities, much like we solved equations earlier in the unit. Your job, your goal today is to be able to teach others how to solve inequalities. Today's notes are the ninth entry in your table of contents, Unit 5, mini lesson number 6 on solving inequalities. So let's get started, okay? To solve two-step or multi-step inequalities, we're still going to use inverse operations, just like we did when we solved equations. To isolate the variable, get it by itself. We're still going to talk about how the equation was built and unbuild the equation, just like we did earlier in the unit. The only difference between equations and inequalities is that there's no equal sign. Instead, there's a less than or greater than sign, just like we talked about Friday. And when you multiply or divide by a negative during your inequality and solving it, the inequality sign is going to flip. Let me show you what in the world I mean when I say that so that there's no confusion, okay? When you are solving an inequality, the inequality sign is going to flip when you multiply or divide by a negative. Let me show you why. So if you look at all four of these cases right here, we're always taking 9 and multiplying it by 3 or dividing it by 3, and taking 6 and multiplying it 3 or dividing it by 3. The only difference is, in these first two examples, we're going to use all positive numbers. We're going to keep everything positive. But in these second two examples, we're going to multiply or divide by negatives, and you're going to see what happens with the greater than sign in the middle. So in all the cases, 9 is bigger than 6. We can agree with that. In these first two cases, 9 times 3 is 27, and 6 times 3 is 18, and 27 is still greater than 18, so the greater than sign can stay there. It still works. In the second case, you're taking 9 and dividing it by 3, that's 3. Taking 6 and dividing it by 3, that's 2. And the greater than sign still works. Yes, it does. Okay? Here in these next two examples, however, we're going to take positive 9 and multiply by negative 27, and we're going to take positive 6 and multiply by negative 3, and that's negative 18. Now, negative 18 is actually bigger than negative 27. So it reads negative 27 is less than negative 18. That greater than sign that was at the beginning, it doesn't work anymore. We multiply by a negative. It doesn't work anymore. Very similar example here. You take 9 and divide it by negative 3, you get negative 3. You take 6 and divide it by negative 3, you get negative 2. Look again at that greater than sign at the beginning. After we divide it by a negative, the greater than sign didn't work anymore. It doesn't work anymore. Okay? Anytime you multiply or divide by a negative and you're solving an inequality, the inequality sign flips. We can solve them using the same rules we did when we solved equations, the same things. We're still going to figure out how it was built and unbuild it. The only difference is when you multiply or divide an inequality by a negative number, you must flip the inequality sign. Let me show you two really good examples of when to flip it and when not to flip it. And then I'll leave you on your own to do some more practice problems with me or with the key. And number 1 here, it says 2y minus 3 is less than or equal to negative 5. Just like before, when we solved equations, we know y was multiplied by 2 first, and then 3 was subtracted from it. So we're going to do the opposite of subtracting 3. We're going to add 3 to both sides. Negative 5 plus 3 is negative 2. Inequality sign is going to stay the same because we have not multiplied or divided by a negative yet. And then 2y minus 3 plus 3 is just 2y. Now, we know that 2y's is less than or equal to negative 2, so we can figure out what 1y is less than or equal to by dividing both sides of the inequality by 2. Negative 2 divided by 2 is negative 1, and 2y divided by 2 is y. This inequality sign stays the same. Why do you think this inequality sign stays the same? That puzzle is going to ask you. That's right, the inequality sign stays the same because even though we got a negative answer, we did not multiply or divide by a negative. We actually multiplied or divided by a positive. We divided by positive 2. So because we did not multiply or divide by a negative, the inequality sign is not going to flip. And number 4, however, very similar. We're going to add 9 to get rid of the subtraction. 11 plus 9 is 20. The greater than sign is going to stay the same because all we did was add, and negative 5a is going to stay there. Now, we're going to divide by the coefficient. We're going to divide both sides by negative 5. Please keep in mind I said we were dividing by negative 5. See that negative sign there? That's right. We're dividing by negative. That means when we find our answer, 20 divided by negative 5 is negative 4. Negative 5a divided by negative 5 is a. The inequality sign, instead of being greater than, is going to be less than. A is less than negative 4. That's the only difference between inequalities and equations. The rest of them, you can solve them just like you would have solved an equation and then write your answer with an inequality. We're also going to ask you to graph some of your answers on a number line, and we'll show you how to do that when you get to our station today. I really appreciate you trying to pay attention to these notes. Remember that everybody is a genius, but if you judged a fish by its ability to climb a tree, it would live its whole life believing that it was stupid. Albert Einstein. Of all the students I've ever taught, you're one of them. Make it a great day or not. The choice is yours. Thank you.